Section 2.8, the quadratic formula and writing functions. Today we are going to solve quadratic functions using the quadratic formula and write a quadratic function given the roots.
Featuring Brendan Wade.
Below you can see the concept summary of the methods we have already used for solving quadratic equations. So we solved using graphing, we've used square roots, we've factored, we've completed the square, and we are finally going to wrap things up with the quadratic formula. The quadratic formula, if we let a, b, and c be real numbers such that a does not equal 0, if you complete the square of the standard form of a quadratic, it will derive the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So when we solve example 2, using the quadratic formula, we need to make sure that our quadratic is in standard form. So we're going to subtract our 12x from both sides. So we get 25x squared minus 20x equals negative 4. We're then going to add our 4 because it's the inverse of subtraction. So we get 25x squared minus 20x plus 4 equals 0. We then know that 25 is our a, negative 20 is our b, and positive 4 is our c. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So at this point we're going to plug and chug our variables into our formula. So we have x equals negative b, which is negative 20, plus or minus the square root of b squared minus 4 times a times c all over 2a. So you want to follow your order of operations to simplify this. So we're going to simplify what's in our radical first. So negative 20 times negative 20 gives us 400. Negative 4 times 25 times 4 gives us negative 400. A negative and a negative outside here gives us a positive 20. And that's all over 2 times 25, which is 50. 400 minus 400 gives us a 0 underneath our radical. Over 50, the square root of 0 is 0. So we have x is equal to 20 over 50, which reduces to 2/5. And there is one real solution for this quadratic equation. Example number 1. Find the zeros of x squared plus 3x equals 5 using the quadratic formula. So shout out from Brendan. He said the first thing we need to do is get it set equal to 0 by subtracting our 5. He's absolutely correct. So we have x squared plus 3x minus 5 equals 0. We now know that our a is our coefficient of our x squared term, so our a is equal to 1. Our b is the coefficient of our linear term, so our b is equal to positive 3. And our c is our constant, which is negative 5. So when we plug it into the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We replace our variables with a, b, and c. So we have x is equal to negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 5 all over 2 times 1. We then can simplify what's underneath our radical. 3 squared is 9. Negative 4 times 1 is negative 4. times the negative 5 gives us a positive 20 all over 2. So x equals negative 3 plus or minus the square root of 29 over 2. So we then want to split it into two problems. X is equal to negative 3 plus the square root of 29 divided by 2. And x is equal to negative 3 minus the square root of 29 over 2. So when you type negative 3 plus the square root of 29 into your calculator and simplify that, you get 2.39, and 2.39 divided by 2 would give us 1.19. So x would cross our axis at 1.19. And when you plug the negative in, negative 3 minus the square root of 29 divided by 2, you get negative 4.19 for our two real solutions. Example number 3, solve negative x squared plus 4x equals 13 using the quadratic formula. First thing we need to do is subtract our 13 so that we have it in standard form. We then can list our a is negative 1, our b is 4, our c is negative 13, and it's time to plug in your variables. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. We then want to simplify what's underneath our radical. Radical is very similar to parentheses. So 4 squared, I get 16. Negative 4 times negative 1 times negative 13 gives me a negative 52 all over negative 2. I then want to simplify further. So I get x is equal to negative 4 plus or minus the square root of negative 36 all over negative 2. The square root of negative 36 simplifies to x equals negative 4 plus or minus 6i all over negative 2. I can split my x into two problems and have x equals negative 4 plus 6i over negative 2, and I have x equals negative 4 minus 6i over negative 2. I then have a nice heart. This is all divisible by 2. So I have actually divisible by negative 2. Negative 4 divided by negative 2 gives us a positive 2. 6 divided by negative 2 gives us a negative 3i all over 1. And when we simplify the other one by negative 2, we get 2 plus 3i over 1. So we have two imaginary roots. The next slide is a quick reminder of when you are finding the roots of quadratic by factoring. Make sure you look for a greatest common factor, set it equal to 0, factor, use the zero product property, set each factor equal to 0, solve using inverse operations. To write a quadratic function when you're given the roots, you are going backwards, so you are starting with your x equals, you're getting it set equal to 0 using inverse operations. Once you come up with your factors, you're distributing those back to one another, and then you get your quadratic y equals ax squared plus bx plus c. So example 4 is just a refresher, writing a quadratic function with integer coefficients that has the roots of x equals negative 2 and x equals 1 over 3. So we need to get these set equal to 0 by using your inverse operations. So we have x plus 2 equals 0. We're going to multiply by 3, so we get 3x equals 1. The inverse of positive 1 is negative 1, so we get 3x minus 1 equals 0. We then can distribute our factors to one another. X plus 2 times 3x minus 1. X times 3x gives us 3x squared. X times negative 1 gives us negative 1x. 2 times 3x gives us positive 6x. 2 times negative 1 gives us negative 2. Combine your like terms and you have your quadratic function 3x squared plus 5x minus 2 equals 0.